Welcome back to Kamal Home Academy, Encounter with the Art and Science of Ceramics. In this session, we will discuss about the determination of hot modulus of rupture. So let us start. Determination of hot modulus of rupture. HMOR, hot modulus of rupture, by ISO 5013. What is hot modulus of rupture? Hot modulus of rupture is defined as the maximum stress that a rectangular bar can withstand at elevated temperatures. Rectangular bar of specified dimensions can withstand at elevated temperatures. When bent in a critical point bending device it is expressed in Newton per millimeter square or MP. A 3-point bending device load is applied at the center of the sample. This is the sample test piece. Load is applied in the center on top. And the load at which it breaks is noted. 3-point bending device like this. Now, what is the dimension of test piece? Now, our purpose of our Modulus of Rupture testing is our Modulus of Rupture of refractories is a very important parameter which controls the quality of refractive bricks or refractive products which are used in furnaces or kilns. Now, test pieces are rectangular bar of 25 millimeter plus minus 25 millimeter 1 mm by 25 mm plus minus 1 mm cross section. And 150 mm length. This is the test size of the test pieces. Now procedure. Now, samples are cut. If the samples are bricks, in the form of bricks, either fired or unfired, test pieces are cut of this size, 25 mm by 25 mm cross section area and 150 millimeter length. And if the refractive, unshaped refractive, for example castables or new generation monolithics, then test pieces are cast in this shape, in molds having these dimensions. Now, procedures. if test pieces are loaded, into the apparatus, shown in the figure. In the Netzsch Apparatus, maximum 30 test pieces can be loaded. Loaded for testing. Now, if test pieces are less, then dummy bars are used to push the test pieces to the loading position. Then heating is started. Heating of test pieces. Is started. The rate of 4 to 6 degrees Celsius per minute. Now, test pieces are heated. The test temperature. Suppose test temperature is 1400 degrees Celsius, then 1400 plus minus 10 degrees Celsius. If test temperature is 1500 degrees Celsius, then samples are heated up to 1500 degrees Celsius plus minus 10 degrees Celsius. If testing is done at 1400, if testing done at 1500 degrees Celsius, and temperature is maintained for temperature is maintained for 15 to 30 minutes. Actually, The soaking time depends on the type of samples. If it is green samples, soaking time may be up to 2 to 3 hours for green samples. If it is unfired, if test pieces are fired, generally fired at 1500 degrees Celsius, and then soaking time during test is given 15 to 30 minutes. Otherwise, if green samples are loaded, then soaking is done for 2 to 3 hours. When samples are heated to the test temperature and temperature maintained for the specified time period, then loading is applied vertically in the center of the sample, just like this, in the center of the sample. The rate of loading depends upon whether it is dense refractive bricks or insulation refractive bricks. After proper soaking, at the test temperature, load is applied vertically. Vertically in the center of the test piece. Now, rate of loading is for dense refractories, dense bricks, at the rate of 0.15 Newton per mm square, and for insulation bricks insulation bricks, rate of loading is rate of 0.05 Newton per meter square. Loading is done till the sample or test piece is broken. Loading is continued till the test pieces breaks. Testing is done one by one and test pieces are pushed to the position of loading position with the help of pushing bar. Load is recorded, load at which test piece breaks is recorded. How to calculate HMOR value? HMOR value is calculated using the formula HMOR equal to 3 WB multiplied by LS divided by twice B to H square, where WB is the load at which test piece breaks. LS is the length of a span rear span. Suppose this is the support and this is the sample. Here loading is from the center. So a span is distance between supports. This is the span LS. This is equal to 125 millimeter. So LS is known, breaking load is known, and breadth of the sample is known. We can measure, and H is height of the sample. This is the height of the sample H. Sample in the form of bar. So this is H and this is breadth D. And a span is somewhere where this is the distance between the two supports is called a span. Is 125 mm. So HMR is calculated using this formula and expressed in Newton per mm square or MPa. It may be converted to kg per centimeter square. Now we will stop here and continue further in the next session. Till then, goodbye and thanks for watching.